for meaning maximum one department who can work for. What about the one command? Each department minimum one employee and maximum n number of employees. So this is another notation. So of the ER schema diagram using min-max notation. So you can see the detailed information like this one, for example. What does that mean? 4, n. Each department should have at least 4 employees. Okay, maximum n. And what about this one? 0, n. Some department may not have any controlling project. Maximum n. What about the project side? Each project should have exactly one controlling department. Okay? So this min-max notation is provide more specific information than regular ER model. Is that the only notation to represent the ER model? No. There are a bunch of other notations. But basically, concept, all of them has the same concept, same contents of modeling. But depending on the name of notation, they use different ways. This is one way. Okay? Sometimes you can use UML diagram. It's exactly same thing as previous one. Also, there are a bunch of other, depending on the author of textbook, some of them like the crowfoot notation. Somebody likes the ABC notation. So if you get used one of them, the others are easy to understand. So please take a look at the notation that they are going to use. However, next week, we will use software. So far, we have used handwriting, okay, to understand. One time, the first project that I joined as a database administrator, it was 20-something years ago. Okay? When I get into my supervisor manager room, his room was covered by the huge size of the ER diagram. That ER diagram includes more than 2,000 entities. And you can count the number of attributes and the relationship. How can he manage? Even every day there are several entities are included and deleted, removed. Definitely he cannot use the handwriting or Lec4. Instead, definitely we need the software to manage such a huge size of diagram. There are many software. You already use it. Some of you guys already use some of them. So one of them is the Visio. Have you ever used the Visio? Yes. It's easy to draw the diagram. Visio is one of the nice, simple tools to manage the database, the ER diagram. Another, one of the most popular the modeling tool is RWin software, the ERWin software. So why don't you go to the careerbuilder.com and type the database related job. Many of the job description include the experience on RWin software, something like that. So that's the only reason I select the RWin software for your practice. I'm not a salesman of that. So next week, the Thursday, we will learn how to use that software to draw the ER diagram, to manage the ER diagram. At that time, RWin software use different notation. Okay? So don't be confused a lot whether this is a new concept or it's the exactly same concept but different notation. Any question so far? Okay. Then, so far we have discussed about the relationship that has two entities. Okay, for example, works for employee and department. Manage employee and department. The control department and project. Dependent and the employee or head. What about the distance supervisor? Even though employee, head, supervise the employee, we can show like that. So all of the relationship include two entities. So that is called binary relationship. So most common the relationships are binary relationships. However, sometimes there are more than two entities are involved to make the relationship. For example, supplier, supply item. This is a binary relationship, as you have seen over there. However, what about supplier, supply item to specific project? How many entities? Supplier, project, and part, item. So three entities are involved in this relationship. Yes, that can be possible. And what else? What can be the other example of such a more than two entities? Each student is entity. Student register a course in specific semester. Register is relationship. How many entities? Student, course, semester. Okay? So even can be more than 3, 4, 5. So that's called annual relationship. Okay? Unfortunately, database does not like such a complicated the relationship. So we need to change such an annual relationship into many binary relationship like this one. For example, supplier supply a part, and part can be supplied to specific project. Supplier support the specific project like this one. So that is supplier supplies project. Supplier can supply a part, and part the project use such a part. Three binary relationship. Do you think they are identical? Yes. One. How we give to one B? What does it mean? Is it same or different? Same and different. The others. It seems to be same, but they are different. Why is that different?
Because of relationship, you have the one-to-many or many-to-many relationship may differ, and also when you use the unique key, that will transfer to the another who has not, like we. So that transfer may.
Do you understand what she is saying? For example, we have a part. Okay, part 1. Supplier 1 supply part 1 to project 1. Okay, that's the example. So you should have the part, only the part that can be used for the project in this case. However, what about this? You may have a bunch of parts, right? Then some of them can be used, the others are not. Okay? It can be also supplier supplies the project, but sometimes no part. Okay? So this one is liberal. Okay? You can have the more information. Not, but this is very strict. That is the same problem with the registration. If we convert registration into student and course and semester, okay? If we convert this one, student register the course, without information about the semester. This is a semester. I'd like to register. I'd like to register. It's kind of plan. Okay, that cannot be guaranteed. Also, student can register specific semester. Okay, what if this semester does not offer the course? Yes, but you can select specific semester. However, even though they are different, we prefer to use such a multiple binary. We will see later why we like the such a thing. That's the limitation of relational database. Okay? Or another possibility is we can create another entity for relationship supply. Then connect all of them using binary. What about this? Not exactly same, but better than this one. Okay. However, this one causes it's a performance problem. Why? You need to check this one. You need to check this one. You need to check this one. There are three. The conditions, right? So anyway, so whenever you have such an binary relationship, you can convert either this one or this. This one used to, this one is bigger. Okay? So this is an example of the binary relationship in the registration. Instructor offered the course in specific semester. Okay? This one is a combination of the binary and ternary relationship that will cause more the performance problem. So for the data modeling tool, there are a bunch of other. Some of them are very popular, like the Irwin or the ER Studio. I think you have heard about the rational rules or many others. Some of them are free, sometimes not. So we are going to use the Irwin software for practice. This is a ER diagram for banking database. Okay. Given ER model, can you understand the meaning of this database, meaning of this information? It's kind of a reverse engineering, right? Now, so last class and today we have talked about the ER modeling from this equation. But this is the reverse way. So given ER diagram, can you understand the meaning of this ER diagram? Yes. For example, there is a bank, can be described by banking code, unique code for the bank, and name and address. It has many branches. Okay? It's a double rectangle, which means it's a weak entity. So using branch number, it cannot be hid. Probably we using identifying relationship, we need the banking code plus branch number to identify the specific branch in this case, something like that. Okay, then why don't you answer the sixth question? So this is your homework that comes by Tuesday. Okay? So do not submit through the Canvas. I'm going to collect only in the classroom. Okay? Yes, hard copy. Either type printed or the handwriting. Okay. So ER modeling itself is very easy, very simple, and very powerful. Okay, that's the benefit of. That's the reason why so many the people are crazy to use the ER modeling. Okay. However, still ER modeling has a limitation. Okay. For example, I identify employee from company database. So it has something information like the social security number, name, and address. Also, by investigating submitted the report and a bunch of description, I realized there are different types of the employee. For example, it has the engineer, also it has a secretary, and it has engineer, secretary, technician. So different types of the secretary employee. How can you represent such an entity using ELA? Another attribute? Okay. So it's another attribute?
Yeah.
So which means like this one.
What?
Type? Okay. So
Type. Was.
type. That is okay. However, I realized that engineer has some more information about the engineer degree. And secretary, we need a typing speed. And technician level. Each of them has their own attribute. Okay.
You have to create
Another attribute, okay.
No, excuse me.
Yeah. Another entity.
Yeah.
Then what about the type?
We didn't,
So you don't agree the creating type, right?
we didn't hear.
So that's the problem. It can be attribute, you can create the type. There's no clear way. Because also, anyway, engineer is an employee, right? Secretary also employee. The technician is also employee. I do not say that she's wrong, he's right, he is wrong, she is right. Both of them are right. Okay? That's correct.
You have to create another entity.
You can create another entity, you can create a bunch of attributes, either way is fine. Okay? But here, it doesn't show clearly the meaning of it. Anyway, all of them are employed, that's true. Which means we can keep as the employee, same entity type. However, each of them has different. So how can we represent? How can we resolve such a problem? How can we address? So this time we can adapt the idea of object-oriented person. Okay, for example, let's say employee is kind of superclass. Then engineer, secretary, and technician, anyway, they are employed, right? So, which means engineer has social security number, name, and address. Secretary has same thing. Technician has the same thing. So, instead of creating new entity, instead of creating bunch of attributes, we can connect them as a subclasses. Okay? Then we can say this is a superclass and these are the subclasses. Okay? This is called extended. Or sometimes enhanced ER model. So this is called EER model. In addition to the ER modeling, we will adapt idea of super and subclasses. Right? Then it's clear. How many entities do we have in this? Employee, super, and subclasses. How many entities?
One.
It's one entity, but it has 4 classes. Superclass and subclasses. Okay? Can you remember the characteristic of the O concept? It has encapsulation and inheritance, something like that. It has inheritance also, which means engineer inherit all the attribute of superclass employee automatically, even though we do not represent this. Do not represent this, it's automatically. Okay? Another characteristic of these super and subclasses is sometimes one employee, as an employee, I can be engineer and secretary. That's possible. Also, I'm an engineer and technician. Also, I'm an engineer and secretary and technician also. So if you allow such a multiple participation of the superclass to subclass, we can say this is overlap. You can represent. That's the reason I use the subcurve between them to represent overlap, which means one employee can be one or more subclasses. Opposite of overlap is disjoint. Disjoint means should be one of this. Okay? Should be one of this. That is the overlap and disjoint. Another thing is sometimes employee does not belong to any of these. It's a partial participation, optional participation. On the other hand, if the employee should be one of these subclasses, we can use double line. This is the mandatory participation. Okay? So this is the characteristic of super and subclasses for ER model, extended or enhanced ER variable. Do you think it's a popular? Yes, it's really popular. That's the reason in computer science we are big fan of the object-oriented concept. ER modeling actually, frankly speaking, ER modeling it's not flexible model. It's a very strong model. It's a very, very strong group. That's the reason sometimes it's very hard to represent complicated relationship. Even ternary relationship is not easy. To address such a problem, we adapt such a super and subclasses relationship, the object-oriented concept, into ER model. Unfortunately, later even though the super and subclasses are very popular in our information, in our daily life, later, when we build a database, this is not possible. Why? It's a relational database, not object-oriented database. So eventually we need to change this kind of format to relational model that we always do. However, the super and subclasses, the relationship are very useful to represent the very complicated concept. We will discuss a little bit more about the extended enhanced ER modeling the next class, Tuesday. So Tuesday we have a class over here, and Thursday after we finish the ER modeling, we will have the first exercise lab in 113, not 163. I changed the room. Okay? We have the 29 students. Any other question? You have a homework by the Tuesday.